Okay, pre-cal students, welcome to the review sheet help class. I will go fast, so pause and rewind if you need to. And I usually make these videos at night, but I'm making this one during the day, so if you hear some background noise, the kids are running through the house and stuff like that. So, okay, here we go. The first section is section 17 through 27 odd. Find the exact value of the function, cosine of 45. We're going to use our special triangles, which should pop up here in a second. There we go. And now let's go ahead and use, not sure why these didn't stick. This is a 30 and this is a 60. All right, now, here we go. We're dealing with 45, so we're going to circle 45. This would be the opposite side. This is your hypotenuse. This is the adjacent. Cosine is adjacent over hypotenuse, so 1 over square root of 2. Multiply the top and the bottom by the square root of 2 to get rid of that radical in the bottom, and you get square root of 2 over 2. Don't reduce those. One's an outside number and one's an inside number. All right, number 19. We're looking at secant of, I'm not sure why these two numbers are not popping up here, 30 and 60. All right, here we go. We are trying to find the secant of 60. And here's 60. Let's circle 60, go straight across. This is your opposite. This would be your hypotenuse. And this here would be your adjacent side. Now, secant is the inverse of cosine. Cosine's adjacent over hypotenuse. So this would be hypotenuse over adjacent. So hypotenuse is 2. Adjacent is 1. So 2 over 1, which is just 2. Moving on to number 21. All right, let's take a look at this. Cotangent of 60. Cotangent of 60. All right, this is my 60 here. I'll go ahead and circle that. Go straight across. This is my opposite. This is my hypotenuse. This is my adjacent. Cotangent is, let's see, adjacent over opposite. It's the inverse of tangent. And so adjacent is 1 and opposite is square root of 3. So 1 over square root of 3. Multiply the top and the bottom by the square root of 3. And you get square root of 3 over 3. Moving on to number 23. Sine of 30. Sine of 30. All right, let's go ahead and fix these two angles real quick. This would be 30, 60, and we're looking at sine of 30. So I'm going to circle 30, go straight across. That's my opposite. This is my hypotenuse, and this would be my adjacent. Now, sine is opposite over hypotenuse. Opposite over hypotenuse, so 1/2. Moving on to number 25. Tangent of 45. Let's go ahead and paste our triangles. And unfortunately, I guess we're going to have to keep fixing these angles every time, so that's fine. Make that a 30 and make that a 60. All right, we're doing the tangent of 45, so circle 45, go straight across. That's my opposite. This is my hypotenuse. This is my adjacent. Tangent is opposite over adjacent, so 1 over 1, which is 1. So the tangent of 45 is 1. Moving on to number 27, cosecant of 30. And make that a 30, make that a 60. And the cosecant of 30, let's circle 30, go straight across. That's my opposite side. This is my hypotenuse, straight across from the right angle. This is my adjacent side here. Cosecant of 30. Now, cosecant is the inverse of sine, and sine is opposite over hypotenuse, so this is hypotenuse over opposite. So that would be 2 over 1, or just 2. All right, moving on to the next problem. I believe now we're looking at numbers 83 through 91, the odds. 83 through 91, excuse me for a second, get a drink of water here. Okay, 83 through 91, the odds. So here we go, guys. Let's go ahead and take a look and see if we can't figure this out. Probably the best way to do these, to be honest with you, is this. I think for these, I should very quickly, let me just think here how we want to do this. We probably want to list out all of our trig values from our special triangles. And so in order to do that, I'm going to have to go back to some previous notes. You should have this in your notes somewhere. There we go. Remember when we took the special triangles and listed out all of the sine, cosine, tangent, cosecant, secant, and cotangent of 45, 30, and 60. You should hopefully remember that. Well, all you have to do is look for sine. Look right here. Sine of a certain angle gives us square root of 2 over 2. Well, let's see. Here it is right here. Look. Sine of 45 gives us what? Square root of 2 over 2. So the answer is simply theta equals 45 degrees. Mr. Earhart, do we have to memorize all 18 of these? No, not at all. You just draw your special triangles and write this out on the test and you're good to go. Okay? But this will be the fastest way to do this section. Okay, let's go ahead and paste these up here. There we go. Now, cosine of theta equals 1/2. So let's see. Cosine, cosine. Here it is right here. Look. Cosine of 60. Let me go back a page. There we go. Cosine of 60 gives you 1/2. So we know that theta has to equal 60 degrees. Right there it is. All right, moving on to number 87. All right, let's take a look here. Tangent of an angle gives me 1. Well, let's see. Tangent. Here it is right here. Tangent of 45 gives me out a 1. So what does theta have to be? Theta has to be 45. So theta equals 45 degrees. Okay, moving on to number 89. Cosecant of an angle. Cosecant gives me 2 square. Here it is right here. Cosecant of 60 gives me 2 square root of 3 over 3. So theta has to be 60. So theta equals 60 degrees. And the last one in this section, number 91, let's go ahead and paste our stuff here. There we go. An angle, when you take cotangent of it, gives you square root of 3. There it is, right here. This one right here. The cotangent of 30 gives you square root of 3. So theta has to be 30. So theta equals 30 degrees. There we go. That's really not too bad, as long as on the test or quiz, whatever, you draw your special triangles and then list out all of these trig values. It's really not too bad. Okay, the next section on your test is the evens 32 through 42, and they want us to round these to decimals, to degrees with decimals. So there's a couple different ways to do it. First of all, I can simply say I have 52 degrees. And then I take 15 minutes, and I always multiply it. One second, please. Okay, we do not multiply it. That's my fault. It's 52 plus 15 over 60. That's one way to do it. If you had seconds, by the way, you would put that number over 3,600. We don't have that, so we don't have to worry about it. But 52 plus 15 over 60 would give you 52.25 degrees. And another way to do it is just simply with your calculator, type in 52 and then hit second apps option 1, and that circle will pop up. Then type in 15, hit second apps option 2, and that line will pop up like that. And then you should be able to hit enter, and that will convert that over for you to 52.25 degrees. All right, moving on to number 34. We would have 64 degrees plus 53 is minutes, so we say 53 over 60. And if you type that into your calculator, 64 plus 53 over 60, you will get 64.88. That's one way to do it, degrees. Or another way to do it is to type in your calculator 64, then hit second apps option 1, and a circle will pop up. Then type in 15, then hit second apps option 2, and this line will pop up, and then hit enter, and you'll get 64.88 degrees. Now some of these might be rounded, understand, okay? I do understand that. All right, number 36. I would have 19 plus 47 over 60 plus 23 over 3,600. And if you type all that into your calculator and hit enter, you will get 19.79 degrees. Now another way to do it is simply type in 19, then hit second apps option 1, a circle will pop up, then type in 47, hit second apps option 2, and this little line will pop up, then type in 23, and then you want to hit alpha plus sign, kind of weird, but alpha plus sign, and these two lines will appear, and then hit enter, and you'll get the exact same thing, 19.79 degrees. Okay, let's move on to number 38. And all these are going to be done the exact same way, students. It'll be 76 plus 11 over 60 plus 34 over 3600. Type all that into your calculator and hit enter, and you should get 76.19. Or the other way, degrees. The other way, of course, is to hit 76. Then second apps, option 1, circle will pop up, then type in 11. Second apps, option 2, this line will pop up, then type in 34. And then alpha plus sign, and these two will pop up, and then hit enter. And you'll get the exact same thing, 76.19 degrees. Moving on to number 40. Let's see, we would have, now be careful here, students. Look, it's not minutes. Do you see that? It's seconds. That's 2 slash marks. So it'd be 68 plus 2 over 3600. Okay? Seconds always go over 3600. Minutes go over 60. And these are seconds. So if you type that in correctly and hit enter, my book says 68.00. They probably rounded that, I'm assuming. But you should get something close to that. Or you can type 68, then hit second apps option 1, and this will pop up. Then hit 2, and then hit alpha plus sign, and this will pop up. And then hit enter, and you should get the exact same thing. All right, moving on to number 42, the last one in the second. Now notice we have no degrees here. Do you see that? We have minutes, so we start off with 44 over 60 plus 10 over 3600. Do you see that? There's no degrees anywhere. And then you type that in your calculator and hit enter, and you should get 0.74 degrees. Another way to do it is to type in 44 and then hit second apps option 2, and this little mark will appear. Then type in 10, hit alpha plus sign, and these two marks will appear. And then hit enter, and you should get the exact same answer. Okay? All right, let's continue on to number 44. All right, numbers 44 through 54, the evens. Now we're going backwards. I'm giving you degrees. You're going to convert them over to degrees, minutes, and seconds. So here we go. The longer way is to write down 20 degrees because you have a 20. Then with your calculator, take 14 or 0.14 times 60, and you will get 8.4 when you do that. Now watch what you do. So you bring 8.4. So you bring the 8 over, not the 0.4. Bring the 8 over, put a mark, and now you take the 0.4. That's what was left over, right? 0.4. Now you take 0.4 times 60, and 0.4 times 60 would be 24. So you have 24 seconds. Okay? Another way to do that would be to type in your calculator, type in 20.14, and then hit second apps option 4, and when you do that, sorry students, hold on 1 second please. What I did is I was on a different screen on my calculator. Sorry about that. Okay, type in 20.14, which you should type that in your calculator like this, and then hit second apps option 4, and when you do that, this is going to pop up an arrow and DMS, then hit enter, and you'll see you get the exact same answer, 20 degrees, 8 minutes, and 24 seconds. Sorry about that little hesitation there. All right, number 46. You have 67 degrees, so you write 67 degrees. Off to the side, you take 0.84 times 60. It's always times 60. And 0.84 times 60 gives you 50.4. 50.4. So you bring the whole number over, which is 50, and you put minutes with it, and you're left over with 0.4. So we take 0.4 times 60, and when you do that correctly, you will get 24. So we then have 24 seconds. Another way to do it is to simply type in your calculator 67.84, then hit second apps option 4, and when you do that, an arrow will pop up with DMS, hit enter, and you'll get the exact same answer. Moving on to number 48. All right, we bring down our 29 degrees, and we're left with 0.8. So off to the side, we take 0.8 times 60, and 0.8 times 60 will simply give us 48. There's no decimal, is there? So we just simply bring 48 over, minutes, and we're finished. That's it. Okay, now another way to do it is to type in 29.8 into your calculator, then hit second apps option 4, and when you do that, this arrow will pop up with DMS, hit enter, and you'll get the exact same answer. Number 50. Well, now this is interesting. Look, we have 0 degrees. Let me rephrase that. We have no whole number degrees. So I'm going to go ahead and put 0 degrees, and then I'm going to take 0.253 times 60 off to the side, okay? And when you do that, you're going to get 15.18, okay? So you bring the 15 over, that's the whole number, put minutes with it, and now the decimal part you're left over with is 0.18. Multiply 0.18 times 60, and of course, if you do that correctly, you'll get 10.8. Now, some books are going to want you to round, you get 10.8. Some books are going to want you to round to 11. I don't care if you put 11 or if you put 10.8. I'm really okay either way, but that's the answer. Now, another way to do it is simply to take 0.253, type that into your calculator, and then hit second apps option 4, and when you do, this will pop up. DMS, hit enter, and you should get the exact same answer. All right, let me take a look here real quick. I probably should be checking these as we go to make sure that I'm getting these right. Let me go back and check a couple. Yep, that one's right, and that one was right. Okay, just making sure we're doing these correctly and not making a little mistake. All right, moving on to number 52. All right, well, we know we have 30 degrees, and then we take 0.2505 times 60, and if you do that correctly, you will get 15.03. 15.03. So we put 15 minutes, that's our whole number, and then we take our decimal part, so 0.03 times 60, and if you do that correctly, of course, you will get 1.8. Now again, I believe our textbook puts a 2. They round it to a 2. You're welcome to put a 2 right here or a 1.8. That's up to you. There's another way to do it. You can simply type into your calculator 30.2505, then hit second apps option 4. Up will pop an arrow with DMS. Hit enter and you'll get the exact same answer. Moving on to number 54. All right, we have 2 degrees. So off to the side, we're going to write 0.4 and multiply that by 60. So 0.4 times 60 would give us 24. And so the answer is simply 2 degrees. We get 24 over here, no decimal, so 24 minutes. Of course, the other way is to type in 2.4 into your calculator, then hit second apps option 4. And when you do, up pops an arrow, DMS, hit enter, and you will get this exact same answer right here. So we're moving right along, guys. On to number 56. Okay, students, numbers 56 through 70 are all calculator problems. And what was I going to say? Every single one, we're taking the sine or cosine or tangent or cosecant or secant or cotangent of a given angle. Okay, so we're going to use our calculators on these. Now make sure you're in the degree mode. So that top row of buttons, the mode button, push mode, and look down at row number 3 and make sure degrees is highlighted. If not, you're going to be getting these wrong, okay? All right, the cotangent of 17. Well, unfortunately, our button doesn't have cotangent, so I want you to type in tangent of 17, and if you do that correctly, hit enter, you should get something like 0.305730, etc. But now we want to invert that or flip it because we are dealing with cotangent, not tangent. So hit x to the -1 button, and up should pop answer to the -1. Hit enter, and you should get the correct answer, which is 3.2709. Moving on to number 58. The sine of 26.1. We'll simply type that into your calculator. Type in sine 26.1, and you should get 0.4399. Moving on to number 60. The cosine of all of this. Well, we know how to do it. First you type cosine, and when you do a parentheses pops up right here, then you hit 74, and then hit second apps option 1, the circle will pop up, then type in 10, then hit second apps option 2, and this little line will pop up, then type in 40, and type in alpha plus sign, these 2 little marks here will pop up, and then simply hit enter, and you'll get the right answer, which is 0.2727. I'm sure all of these are rounded. All right, let's take a look at number 62. The cosecant of 45.2. Now, cosecant is not on your calculator. So, the inverse of cosecant is sine. So, I'm going to take the sine of 45.2. Now, if you type that into your calculator correctly, sine of 45.2, you should get 0.7095707365. Now, we're not trying to find the sine of 45.2. We're trying to find the cosecant. So now you've got to take this. It should be on your screen. Hit the x to the -1 button, and when you do, this should pop up on your screen. And then hit enter, and you should get the correct answer for number 62, which is 1.4093. 1.4093. Moving on to number 64. Now we do have a tangent button, so you simply hit tangent on your screen. Up pops a little parentheses. You then type in 63, and then second apps option 1. That circle will appear. Then type in 48, and then second apps option 2, and up will pop that little line. Then hit enter, and the correct answer should be 2.0323. All right. There's your answer, and we're moving on to number 66. Cosine of 4. Well, students, it doesn't get much easier than that. Type in cosine of 4 and hit enter, and you will get 0.9976. Let's move on to number 68. Okay, students, now we're looking at secant of 35.28. There is no secant button, so the inverse of secant is cosine. So in your calculator, you would type in cosine, up pops a little parentheses, you type in 35.28. And let me grab my calculator. If you do that correctly, cosine of 35.28, you should get 0.816339250. And of course, we don't want to know what the cosine of this angle is. We want to know the secant. So we then hit x to the -1, and when you do that, this will pop up on your screen. And the answer then should match the one in the book, which is 1.2250. And of course, that's rounded. 1.22, I think it's 498, but you round that, it's 1.2250. All right, moving on to number 70. Number 70, sine of 59.2. Well, there's no trick to this, students. You simply type in sine 59.2 and hit enter, and you will get the correct answer of 0.8590. All right, let's move on now to number 72, which starts a new section on the review sheet. And now we're looking for the missing angle. There are 5 of these, and these are a lot tougher. So I hope you'll really give me your undivided attention here and really pay attention. Okay, here we go. Tangent. Now we're trying to find an angle. Whenever you're using a missing angle, that's when you want to hit second tangent. Okay, so sorry about that. Notice in the previous problems we were not looking for an angle. They gave us an angle. Okay, now we're looking for the angle. So when that happens, it's tangent of a certain angle gives you 2.032. So with your calculator, hit second tangent, and when you do that, this should pop up on your screen. Tangent of -1 with a parentheses. And then in that parentheses, you're going to type 2.032. And then hit enter, and you will get out the correct answer for that. And the answer is, you should get 63.8 degrees. So theta equals 63.8. In other words, when you take the tangent of 63.8, you should get 2.032 or something close to that, because this is a rounded answer. All right, number 73. We're looking for an angle. So we hit second cosine, and when you do that, up pops cosine to the -1 with the parentheses, and then you type in 0.3842, and then hit enter. And if you do that correctly, what you should get is rounded 67.4 degrees. So what that means is that's what theta equals 67.4. So if you were to take the cosine of 67.4, you will get 0.3842. All right, number 76, the tangent of tangent of an angle that gives you 3.056. We're looking for an angle. So we hit second tangent, and up pops tangent to the -1. And then in parentheses, you would type 3.056 and hit enter. And what you would get for theta for number 76 would be 71.9 degrees. So tangent of 71.9 should give you 3.056. number 78. We're looking for this missing angle. So we hit second sine, and when I do, pop sine -1 parentheses, and then type in 0.4005, hit enter, and you'll get theta equals 23.6 degrees. So in other words, what that means is if you take the sine of 23.6, you would get 0.4005 or something close to that. Number 80. Good, a tougher one. I've been waiting for that to happen. Okay, we don't have a cosecant to the -1 button on our calculator. So here's what you do. You write the inverse of this side. Well, the inverse of cosecant is sine. So I'm going to write sine theta. Got it? Now you're like, Mr. Earhart, you can't just write the inverse of one side without doing it to the other side. And I say you're right. So let's write the inverse of this side. The inverse of cosecant is sine. The inverse of this side, remember, even though you can't see it, you can put any number over 1. So if we flip this and get the inverse, we have 1 over 1.147. So we rewrote the problem from here to here. So now let's go ahead and solve this. So I would type second sine, and up pops sine to the -1, and then parentheses, and then type in 1 divided by 1.147, and then close the parentheses and hit enter, and you should get 60.7 degrees. So in other words, if you were to take the cosecant of 60.7, you will get 1.147. And the last one in this section, number 82, cotangent of a certain angle. Let me get a drink of water here, excuse me. Cotangent of a certain angle gives you 1.351. We don't have a cotangent to the -1 button. So we're going to write the inverse of this side. The inverse of cotangent is tangent. Now if I write the inverse of one side, then I've got to write the inverse of the other side. So we flip this. It's really over 1. And I'm going to go ahead and flip it. And when I flip it, I get 1 over 1.351. So now go ahead and hit second tangent, and up pops on your screen tangent to the -1, because you are looking for an angle, and then you type in 1 divided by 1.351, and then go ahead and hit enter, and you should get the right answer, which is 36.5 degrees. So what that means, in other words, if you were to take the cotangent of 36.5, you will get 1.351. Okay, hope you're getting this. Let's move on to the next problem, which is number 97. Now, I need you to turn your books to page 445, number 97. I'm not going to write all these down for you, but do you notice in the book on number 97, they give you a bunch of 65-degree trig values, sine of 65, tangent of 65, secant of 65, etc., etc. Well, remember, 65 plus 25 equals 90, right? Think about that. 65 plus 25 does equal 90. So I want to find the sine of 25, and it says not to use a calculator. It says given those 6 values there, then use those 6 values to help you find the 6 values of 25 degrees. So we're dealing with cofunction. This was in your notes yesterday, I believe, maybe yesterday or 2 days ago. Cofunction identities. And the cofunction of sine, now I know the inverse of sine is cosecant, but the cofunction trig function for sine is cosine. So I'm going to write cosine of 65 degrees equals, I'm going to look in my book, and there it is, 0.4226. I'm not sure why I'm way over there. Pull that back over real quick where it's supposed to be. There we go. Now, remember what I said. If you have sine and cosine, and both degrees add up to 90, then the answers will be the same. So the answer to the sine of 25 is 0.4226. Let's try it with cosine here, okay? Cosine of 25 degrees. Well, let's take a look here. The cofunction of cosine is sine, so I'm going to write sine of 65. And I can find that in my book under number 97. So the sine of 65 would be 0.9063. So 0.9063. And so notice I have cosine and sine. They're cofunctions. 25 and 65, they add up to 90. So this answer would also be 0.9063. Now I'm not going to keep writing all these for you. You're older kids and you want the video to go fast. And I do too. I'm the same way you are. So there's not a need to keep writing all these down, but I'm going to say them out loud though. Now the cofunction identity for tangent is cotangent. And so the cotangent of 65 is, you can look in your book and see what it would be. It would be 0.4663. So I have tangent and cotangent. 25 and 65 add up to 90. So it would be the exact same answer as the cotangent of 65, which is 0.4663. Now, the cosecant of 25. Well, the cofunction of cosecant is secant. Secant of 65 degrees. Now, you can look in the book and see what that would be. Now I have cosecant and secant, they're cofunctions. 25 and 65 add up to 90, so they have to have the same answer. So the cosecant of 25 would be 2.3662. Now here's secant. The cofunction of secant is cosecant. Cosecant of 65. And so notice I have secant and cosecant. 25 plus 65 is 90. So whatever the cosecant of 65 is, then that would also be the same answer for secant of 25. And that answer would be 1.1034. 1.1034. Okay, cotangent of 25. Now, the cofunction of cotangent is tangent, so I'm going to write tangent of 65. Now, notice what I have. I have cotangent and tangent. 25 and 65 add up to 90. So the tangent of 65 is 2.1445. So it's got to be the exact same thing for this, 2.1445. All right, I know I've gone fast. If you got to back it up, feel free to do that. And we're going to go ahead and continue on here. Now, I'm going to get a little more room for this problem. All right, this is number 98 on your review sheet. And here we go. Look at 98 in your book. Notice that we're dealing with 8 degrees, 8 degrees, 8 degrees, 8 degrees, 8 degrees, and 8 degrees. Well, that makes sense because we have 82 degrees over here. And 82 plus 8 is 90 degrees. So let's go ahead and see if we can't figure this out. Sine of 82, so I'm going to go ahead and write my cofunction. That'd be cosine of 8 equals, now I have sine, cosine, they're cofunctions. 82 plus 8 is 90, so the cosine of 8 degrees is 0.9903, so this must also be 0.9903. Next is cosine of 82, so I'm going to write the cofunction, which is sine, sine of 8 degrees, and notice what I have. Cosine and sine, they're cofunctions. 82 plus 8 is 90. The sine of 8 degrees is 0.1392, so this answer right here must be 0.1392. All right, tangent of 82. Well, the cofunction for tangent is cotangent, and 8 degrees. Now notice what I have. I have tangent and cotangent. 82 plus 8 is 90. Cotangent of 8 degrees is 7.1154, so this answer here would also be 7.1154. Moving on, the cofunction of cosecant would be secant, and we're going to go ahead and put 8 degrees. Now look what I have. I have cosecant and secant, they're cofunctions. 82 plus 8 is 90. The secant of 8 degrees is 1.0098, so this answer must also be 1.0098. Next I have secant of 82, so I'm going to write the cofunction, which is cosecant of 8 degrees. Now notice what I have. I have secant and cosecant. 82 plus 8 is 90. The cosecant of 8 degrees would be 7.1853. So this answer must be 7.1853. Wow, finally, last one. Cotangent of 82. The cofunction of cotangent is tangent. I'm going to write tangent of 8 degrees. Now look what I have. Cotangent and tangent are cofunctions. 82 plus 8 is 90. The tangent of 8 degrees is 0.1405, so this answer right here must also be 0.1405. Wow, that was a lot. Okay, that was numbers 97 and 98. I hope that helped. Let's continue on now to number 7 on a new page. And let me very quickly look that page up. That page, give me 1 second. That page would be, I believe, page 529. All right, number 7 says find the 6 trig functions of theta. 6 trig functions of theta. So here's theta. Go straight across. This is your opposite side. This is your hypotenuse. This is your adjacent. And here we go. The sine of theta, opposite over hypotenuse. That would be 3 over the square root of 73. multiply the top and the bottom. Actually, let's do that a little later. I think that'd be helpful. I'm going to go ahead and do the inverses right now and just get it over with. So we have sine of theta is this. So the inverse of sine is cosecant of theta, and the cosecant of theta would be square root of 73 over 3. All right, sine, let's do cosine next. Cosine of theta, that's adjacent over hypotenuse, so that would be 8 over square root of 73. So the inverse of cosine is secant. So secant of theta would be square root of 73 over 8. Very good. And then the tangent of theta would be opposite over adjacent, so 3 over 8. The inverse of tangent is cotangent, and the cotangent of theta would then be 8 over 3. Cool beans, moving right along. Now, we got to rationalize here and here, so we're going to multiply the top and the bottom by the square root of 73 over the square root of 73. That would give you 3 square root of 73 over 73. 3 and 73 cannot be reduced, so we're not going to reduce this. And then here we're going to multiply the top and the bottom by the square root of 73. Square root of 73. 8 times square root of 73 would be 8 square root of 73. And square root of 73 times square root of 73 is 73. So there we go. Pretty simple. And we're moving on. That's the 6 trig values of theta based on that right triangle. Okay, next is number 8. The number 8 is a little more difficult, so please pay attention. Number 8, they're telling us the sine of b is the square root of 91 over 10. Now please pay attention and watch what I do. First of all, I'm going to draw my right triangle. It doesn't matter how big you draw it, how small. That's not really a big deal. I'm going to move it up here to give me a little more room. All right. Now, remember, sine is opposite over hypotenuse, okay? It doesn't matter what angle you call beta. Just put your right angle here. We'll call this angle here angle beta, okay? So this is my opposite side, go straight across. And opposite, if you'll look at your fraction here, the opposite side is square root of 91. Now the hypotenuse is the bottom number here, 10, so this is 10. So students, what I have to do now is I have to find this missing leg. So we use Pythagorean Theorem, L squared plus my other leg, which is square root of 91 squared, equals the hypotenuse squared, 10 squared. Now, when you square a square root, the square root of 91 times the square root of 91 is just going to be 91. And 10 times 10 is 100. Now next I'm going to bring this 91 over and make it a negative 91. When I do that, I'm left with L squared equals 9. Now take the square root of both sides, and L equals 3. So my missing leg is 3. All right, now go back and watch that again if you need to. I'm going to go ahead and try to get this eraser to work a little better. There we go. Now, here's beta. So I go straight across. This is my opposite side. This is my hypotenuse, and this is my adjacent. Well, I already know what sine is, so we're good there. Cosine, and actually, I'll be honest with you. Well, I'll go ahead and finish it. I was going to say now it's just like the last problem where we wrote everything out, but that's fine. Let's go ahead and write down sine right here. Sine of b is square root of 91 over 10. So then the inverse of that is cosecant of beta would be 10 over square root of 91. And of course, we're going to multiply the top and the bottom by the square root of 91. That would give us 10 square root of 91 all over 91. Next is cosine of beta, and cosine is adjacent over hypotenuse, so 3/10. The inverse of cosine is secant, and so the secant of b would be 10/3. Now let's continue on to tangent. The tangent of b is opposite over adjacent, so square root of 91 over 3. And so then the cotangent of beta would be 3 over square root of 91. So we're going to multiply the top and the bottom by the square root of 91, which would give us 3 square root of 91 all over 91. There we go. We did it. We listed out all the trig functions, and all that we knew was this one little bit of information right here. And from that, we were able to draw a right triangle, label two sides, use Pythagorean's theorem to find the third side, and then find the rest of our trig values. All right, let's continue on now to number 46. Number 46, of course, is on page 53. And here we go. Let's go ahead and factor our numerator. That's the first thing you do when you're dividing rational expressions. So let's go ahead and factor this. Pull out what's common, which is a 3, and you're left with x squared minus 4. Then you notice you know the square root of both of these. One's positive, one's negative. So we put two little parentheses, and we're going to write x plus 2, x minus 2. And there, we have factored the numerator. Let's go ahead and write that up here. And now let's move on to the denominator and see if we can't factor that. All right, let's see here. I have a trinomial. There's nothing common I can factor out. I have a lead coefficient of 1. So I'm going to list out all the factors of 4 and see if any of those add up to 4. Well, obviously it's going to be a positive 2 and a positive 2 because 2 times 2 is 4 and 2 plus 2 is 4. So the factorization would be x plus 2, x plus 2. All right, so there's the factorization of that. Let's get this out of the way. I'm going to erase very carefully here. And now let's pull this up. Now, students, you can't factor x minus 2. It's a binomial. You do not know the square root or the cubed root of either term. Same thing with x plus 2. However, we do need to switch the signs around, okay? So like this negative sign here. That was really good. Let's see if we can't do that, and then that, and then that. So we're going to put the x minus 2 on the bottom and the x plus 2 up top. So we simply flipped that fraction. Why do we do that? Because we're dividing, and now we're no longer dividing, we're multiplying. Okay? So let's start crossing things off. I have an x plus 2 and an x plus 2. I have an x minus 2 and an x minus 2. And look at this. X plus 2 cancels vertically with x plus 2. Nothing left here, so I have a 1. Nothing left here, so a 1. Nothing left here, so a 1. So I have 3 times 1, which is 3. 1 times 1 is 1. So 3 over 1, or 3, is your final answer. All right, let's move on to number 47. Now, notice we're not multiplying or dividing. We are subtracting, so we are going to have to find a common denominator. Now, I look at this. I have a trinomial. There's nothing common I can factor out, and I'm thankful that I have a lead coefficient of 1. So I'm going to list out all the factors of 20 until I come to these two numbers right here, a positive 4 and a positive 5. When you multiply them, you get 20. When you add, you get 9. So we're totally good with factoring. Our factorization would simply be x plus 4, x plus 5. Okay? And so let's go ahead and do this and slide that out of the way. And now our denominator has changed to this right here. All right, now let's go ahead and factor this denominator over here. Notice there's nothing common that I can factor out. And so I see that I'm left over with the trinomial lead coefficient of 1. So I'm going to list out all the factors of 12 until I come up with one that adds up to 7, which would end up being a positive 4 and a positive 3. When you multiply those, you get 12. When you add those, you get 7. And so I'm going to factor this. I would get x plus 4, x plus 3. All right? Now, next, I have to find a common denominator, okay? And what I've taught you to do is let's compare binomials with binomials, trinomials with trinomials, etc., etc. Now, when I look at this denominator here, I have one group of x plus 4 and one group of x plus 4. So I know at the most which one has the most. Well, they both have 1. So I know my common denominator needs 1 x plus 4. Now I have one group of x plus 5, no groups of x plus 5. Which one has the most? This one does, and it has 1. So I know I need 1 x plus 5 for my common denominator. And I continue on. I can check that off, Okay, x plus 4 I've already done. X plus 3. I have one group of x plus 3 here. I have no groups of x plus 3 over here. So which denominator has the most? Well, this one does, and it has 1. So I know that my common denominator is also going to need an x plus 3. Okay? So I go ahead and write this. Actually, I'm going to take that off and try to save a little bit of time. That is not what I wanted to do. Yeah, that's going to mess everything up, so I apologize. Okay, I'm back now, and hopefully it's taking care of all the problems. There we go. Okay, very good. So let's continue on. There's my other common denominator for my other fraction. And let's put a minus sign between the two. And next, here's what we do. Whatever's in the numerator, we always bring that down. So we're going to bring down the x and put it right here. And then we say, what do we have extra here that we don't have here? Well, looks like an x plus 3, so parentheses x plus 3. And then here, bring down your 4 from the numerator, right up here. Bring down your numerator, which in this case is a 4. And then what do I have extra here that I don't have here? Well, it looks like an x plus 5 to me, so I'm going to write x plus 5. Now next, we're going to combine the two fractions. And what I've said all along is you don't have to keep writing this real big denominator. Just put CD for common denominator. So x plus 3, then minus 4, x plus 5. So we're putting the two fractions together. And then you would write your common denominator. I'm just going to put CD. Now obviously we're going to need more room in the next page, so let me go ahead and get a new page up here, and let's see if we can't slide this over real quick to our next page. Alright, now I've combined my fractions. Now I have to simplify the top, or my numerator. So x times this group would be x squared plus 3x. Now be careful, you're not multiplying a 4 through, you're multiplying a negative 4 through. So negative 4 times x is negative 4x, and negative 4 times 5 is negative 20, all over your common denominator. And then go ahead and add your like terms. So we would have x squared minus 1x, or just minus x, because these are both x terms. You can put them together, and then minus 20, all over your common denominator, which I forget what that was. 4, 5, and 3. So x plus 4, x plus 5, x plus 3. Okay? And there we go. We did it. That is the answer. Took a lot of time, but that is how you would do that. All right? Let's go ahead and continue on. All right, number 54. Now we're getting into a bunch of equations, solving them, and you're always going to want to check to see if they're linear or quadratic. If this x was squared, it'd be quadratic, but it's not squared, so we have a simple linear equation. So we want to get x by itself. We bring the negative 7 over. When we do, it becomes a positive 7, and we're left with 2x equals 14. Now divide both sides by 2, and x equals 7. Number 54. Okay, moving on to number 55. Notice your x's are not squared, so we have a simple linear equation. I'm going to get the x's on one side, so bring my 3x over and make it a negative 3x. Bring my negative 7 over and make it a positive 7. So when I do that, I have a negative 3x here, and this 3x is gone. I have a positive 7 over here, and this negative 7 is gone. And so I should be left with 2x equals negative 2. 2x equals negative 2, divide both sides by 2, and x equals negative 1. All right, moving on. Number 56, same type of problem. I'm going to get my x's on one side. I'm going to bring my negative 2x over, or my positive 2x, and make it a negative 2x. I'm going to bring my positive 8 over and make it a negative 8. And so when I've done this, I will have a negative 2x here, and this positive 2x is gone. I will have a negative 8 right here, and this positive 8 is gone. So I should be left with negative 5x equals negative 15. Now if you divide both sides by -5, negative 15 divided by -5 is 3. And that is the correct answer. All right, number 57, notice none of your x's are squared, so you do not have a quadratic. So we're going to simplify both sides as far as we can. Over here I can take 6 times 2x and 6 times -1. If I do that correctly, I will have 12x minus 6. And then over here, please don't take the 3 and multiply it through. If the 3 was right next to the parentheses like that, then you would multiply the 3 through. But it's not, it's way over here. Now you're going to multiply a negative sign through, a negative times the x, and a negative times the 10, which will change the sign. So your positive x becomes negative x, your positive 10 becomes a negative 10. And now look, you cannot simplify any more over here. However, you can simplify these two terms right here, a positive 3 and a negative 10. So let's go ahead and put those together and simplify. And if we do that, a positive 3 and a negative 10 is a negative 7, and then bring down your negative x. Over here, we bring down 12x minus 6. Now I want to get my x's on one side, so bring this over and make it a positive x. Bring your negative 6 over and make it a positive 6. And if you do that correctly, you will have a positive x here, and this will totally be gone. You have a positive 6 here, and this will be totally be gone, and you're left with 13x. Now where'd that come from? Well, 12x plus 1x. Hold on one second, please. 12x plus 1x would be 13x. And then this was a negative 6, I believe. Is that correct? Yes. So a negative 7 and a positive 6 gives you a negative 1. And then divide by 13. Now you're going to get a fraction, but negative 1 divided by 13 is simply negative 1/13, which is the correct answer. All right, notice we have a quadratic now, okay? Hold on one second here. Okay, notice we have a quadratic here. Now, on the test, I'm going to have you factor some, and I'm going to have you use the quadratic formula on some, okay? Let's go ahead and factor this one. Now, you always want to get one side equal to 0 before you factor, okay? And if you do not know that, be sure and remember that. You must bring everything over. That's already done for you here, but always do that first. So, we've got one side equal to 0. We moved everything over here to the left side. Now we're going to factor this. It's a trinomial with a lead coefficient of 1, so we're going to list out all the factors of 64. Now the factors we're looking for are positive 8 and positive 8, because when you multiply those you get 64, when you add those you get 16. So the proper factorization would be y plus 8 equals 0. All right, easy enough. Now, what we do next, because we're solving, is we say to ourselves, okay, what would make this parentheses become a 0? Well, obviously, y would have to be a negative 8. And what would make this parentheses become a 0? What would you have to put in for y? Well, negative 8. So your answer would be y equals negative 8. No need to write the same answer twice. Okay? That's called solving a quadratic by factoring. Now let's solve this quadratic by using the quadratic formula. Negative b plus minus the square root of b squared minus 4ac all over 2a. And yes, that is a 4 right there. All right, let me quickly grab a drink of water. I've been talking for a long time here. Okay, just like factoring, to solve quadratic equations, you do not want to factor unless one side is equal to 0. Well, you do not want to use the quadratic formula unless one side is equal to 0. So bring the positive 20 over and make it a negative 20. And now whatever is in front of the x squared is your a, so a equals 1. Whatever is in front of your x is your b, so b equals negative 1. And then the constant term is always your c, so c equals negative 20. Now please watch what I do. I'm going to draw a little line here to keep us from getting a little unorganized. See this negative 1 right here? I'm going to put that in for b. But if I put that in for b, notice what's already on the outside, a negative sign. So I really have a negative 1. So that would give me a positive 1. And then plus minus, now be careful here, the square root of b squared. Okay? B squared, well, b is negative 1. Negative 1 times negative 1 is 1. And then minus 4. Now you should be able to do AC in your head. A times C. 1 times negative 20. And that would give you a negative 20. Okay? All over 2 times A. Well, A is 1, so 2 times 1 is 2. Now, inside your radical right here, the number one mistake that students make next is they take 1 minus 4, and that's wrong. You take negative 4 times negative 20. You do your multiplication first, and then add a positive 1. So I have 1 plus minus. Now watch what I do. I bring down my positive 1 right here, this positive 1. I bring it down, okay? And then I multiply negative 4 times negative 20. That's a positive 80 all over 2. And then, of course, 1 plus 80 is 81. So now I have 1 plus minus the square root of 81 all over 2. And, of course, what is the square root of 81? It's 9. So 1 plus minus 9 all over 2. Now, that breaks down to two different fractions. 1 plus 9 all over 2 and 1 minus 9 all over 2. Now we should be able to put the answers right here in this circle. X equals, what is 1 plus 9? It's 10. And what's 10 divided by 2, or 10 over 2? 5. So there's one answer. What's 1 minus 9? Negative 8. Negative 8. And then negative 8 divided by 2 would be negative 4. So those are your two answers. Okay? All right. Hopefully you're getting this, and I believe we're on our last problem. So yeah, awesome. Okay, let's go ahead and solve this by factoring. So here we go. Notice I have one side equal to 0. That's good. Next, I notice that I have a trinomial that does not have a lead coefficient of 1. So in my head, I take this first number 2 times negative 6, and I write that number right over there, which would be negative 12. And I'm going to list out all the factors of negative 12 until I find one that works with positive 11. Well, it's going to be a negative 1 and a positive 12, because if you multiply those, you get negative 12. If you combine those, you get a positive 11. So where this positive 11x is, I'm going to write these two terms right here. So negative 1x and positive 12x. And then bring down your negative 6, and then bring down your 2x squared. And now we simply have a 4-term polynomial right here. 4-term polynomial to factor. So we factor by grouping. Let's pull out what's common. I think my son has a question. Mike, this is the last problem and I'll be done, okay? Let's pull out what's common in the first two terms right here, which would be an x. And that would leave me with 2x minus 1. Then over here, pull out what's common. Notice there's a positive sign here, so you pull out a positive. If this was negative right here, then you would pull out a negative sign. Don't forget that. We've learned that, just reminding you. Pull out a 6, and that would leave you with 2x minus 1. So my parentheses do match, so I write my matching parentheses once, 2x minus 1, and you're left over with x plus 6. Now, we're almost done. What would you put in for x that would make this parenthesis 0? Well, that's easy. Negative 6. So there's one answer. This one's not so easy. Now, I could see personally it would be a positive 1/2, because 2 times 1/2 is 1 and 1 minus 1 is 0. But if you can't do that one in your head, then come off to the side and take that parentheses that you're struggling with and set it equal to 0, and then solve. Bring your negative 1 over. When you bring it over, it becomes a positive 1. Then divide both sides by 2, and x equals 1/2. So there's your two answers. Wow, this has been a really long video for me. My voice is shot. I hope you guys are using this to help you get your questions answered, and hopefully to get you ready for your test.